Hey guys, welcome to the next video on OpenCV tutorial for beginners using Python. In this video, we will see how we can perform object detection using HSV color space. Now we have already seen how to work with BGR or colored images or grayscale images. And we have already seen how we can convert from colored images to grayscale images. So there are more than 150 color space conversion methods in OpenCV, and one of them is colored image to HSV image. Now what is HSV color space? So HSV stands for hue, saturation, value. So H stands for hue, S for saturation, and V for the value. Now generally RGB in RGB color space are all correlated to the color luminance. That is what we loosely call intensity. In other words, we cannot separate color information from luminance. So HSV or hue saturation value is used to separate image luminance from color information. So this makes it easier when we are working on or we need luminance in our images. That is why generally we use HSV in the situation where color description plays a very important role. Now, as I said, HSV stands for hue, saturation, and value. But what is the meaning of each and every single word in HSV? Now, HSV is also known as the hexagon color model. So this color space can be described in this kind of cylindrical cone model where hue is this circular angle which varies from 0 to 360, and hence just by selecting the range of hue you can select any color. So you can see different colors are available at different angles. So these colors are basically red, yellow, green, cyan, blue, and magenta. So hue is this angle in this cylindrical cone. Now we have saturation. So the saturation is amount of color, that is the depth of pigment or the dominance of hue. And this value is described from the center towards the outer layer of this cylindrical cone. So here you can see at the center this saturation start at 0 and it can go up to 1 at the end of this cylindrical cone, and this saturation can be increased from 0 to 100%. Similarly, the value is basically the brightness of the color. So this brightness can be increased from 0 to 1 from the bottom of the cone to the top of the cone. So all these three values, hue, saturation, and value, can be used to pick any color as we can do with the BGR color space. So this is the brief introduction about HSV color space. And now let's see how we can use this HSV color space to detect an object in an image. So here I have this simple code to load an image using imRead method and show it inside a window. So by now you might already know how this code works. So let's run this code and let's see what does this code do. So I have this image which is called smarties.png, and here are some circles in different colors. So we have blue circles or green or red, orange, and brown circles here inside this image. So let's say we somehow want to detect only the blue circles or balls or green circles or balls. How can we just detect only these balls? Let's say we just want to detect the green balls. How can we achieve this using OpenCV? We are going to see this using this HSV object detection. And here we have one more window, which is the tracking window, which is coming from this code, which is cv2 named window, and the name of the window is tracking. So this tracking window we are going to use little bit later when we will add the track bars to our image. But let's say we want to use this image and detect these colored balls. So first of all, after this image is read, what we want to do is we want to convert our colored image into our HSV image. And by now you might already guess how to convert an image. You can just write HSV is equal to cv2.cvt color, and then your frame name, which is frame in this case, and then cv2 dot whatever color space you want to convert from and whatever color space you want to convert to. So you can just write color underscore bgr to HSV. So this is the property we are going to use. Now in the next step, we will threshold the HSV image for a range of blue color. So we are going to just define L underscore B for lower blue color, and then we are going to use the numpy array, so np dot array, and inside this array we are going to define the lower range of blue color. Now by experience I know that these HSV value for lower blue color will be 110, 50, 50, right? But you might not have every time the idea what is the lower color range or the upper color range of some color. So that is why later in this video we will use the track bar in order to perfectly define the lower and upper values for this HSV color space, right? So right now I'm just going with my experience. So for the upper value I'm going to define the next variable, which is ub is equal to np dot array, and then once again I'm going to define these three color channels, which is 130, 255, 255. So this will be the upper limit for the blue color for our HSV image. Now in the next step, what we are going to do is we are going to threshold the HSV image to get only the blue color, let's say. So I'm going to just define a variable called mask here, and then I'm going to use cv2 dot in range method, where I will provide first of all my HSV variable or image, and then I will provide the upper and lower range for this function. So my lower range is this numpy array for the blue color. So I'm going to just say L underscore B is my lower range and U underscore B is my upper range. Now we have already seen how we can use bitwise AND or bitwise operations on images. So what we are going to do next is we are going to define a variable called res, and then we will just call cv2 dot bitwise AND to mask the original image. So here the first value will be our frame, which is the colored frame, right? So this is the frame which we have read from this image, which is the Smarties image. So this is the source one. Source 2 will be the same. So the frame itself will be the source 2. And what we want to do is we want to provide the mask of the lower blue color and the upper blue color values, right? So here we can just say mask is equal to whatever mask variable we have created. So this is the attribute we can set in order to apply the mask for the lower blue value and the upper blue values. So once we have this result frame, what we can do is we can use this cv2.imShow method in order to show the mask, let's say. So we are going to show the mask and we are going to show the result using res variable. So this is going to open 3 windows, and let's see what happens when we run this code. So we are going to run this code and this opens 3 windows here. And now you can see the mask first of all. So we are just detecting the blue colored balls using this mask. That's why we have defined the lower boundation of the blue color and the upper boundation of the blue color, right? So that's why it's only detecting, you can see the blue ball is here, here and here, and here also you can see the mask also detects only the blue values here, right? And then in the result you can see when we have applied this mask and we have masked all the other things other than the blue colored ball, you can see only the blue balls here. So the same method you can apply to detect any other colored ball from this image. Now, as I said, it's not easy to detect these lower and upper boundation for the colors. So that's why you can use the track bar for adjusting these lower and upper boundation of any color. So for that, what we are going to do is, first of all, we will create a named window, and then we are going to create a new window which we will use to adjust the lower and upper boundation of HSV values. So now I'm going to just use CV2 dot. We have already seen how to create a track bar, so I'm not going to explain in detail how this works, but let's say this track bar name is lower hue for LH. Okay, so this is the lower hue value, and then the name of the window, which is tracking, which is this one. So we are going to provide the name of the window, and the next argument will be the starting and the ending values. So we are going to define the start value 0 and the end value, let's say we are going to define the 255 here. Okay, and the last thing we want to give here is the callback function, which I have already created, which is this function, which is just doing nothing. We are going to just provide this callback function as a dummy function, so it's not going to do anything. So this is the track bar for the lower hue value. Similarly, we are going to define the track bar for lower saturation and lower value, and upper saturation, upper value, and upper hue. Okay, so this will be lower saturation, this will be lower value, and then this will be UH, which is upper hue, and then this will be US for upper saturation value, and this will be upper value, right? So HSV lower values and HSV upper values. So here we are going to set the initial value for the upper value. So let's say everything is set to the maximum, so 255, 255 and 255 here. Okay, so the lower values are set to zeros and upper values will be set to 255. Now you already know how to get the values from a track bar. So you can use, for example, L underscore H for the lower hue values is equal to CV2 dot get track bar position. So just use get track bar position method, and then first of all give the name of the track bar from which you want to get the position. So let's say we want to get the position from the LH track bar, and then the name of the window, which is tracking in our case. So here is the second argument, and similarly what we are going to do is we are going to define the other lower values and upper values. So and also the name of your track bars. So once you have the values of lower HSV and upper HSV, you can provide these values here in place of these static values. So first element of this array will be LH, and then the LS variable, and then the LV variables. Similarly, for the upper boundation, we will provide these three upper boundation variables. And now when we will run our code, let's see what happens. So we are running our code, and you can see these windows, these three windows. One is the mask, other is the result, and the third one is the frame. And we also have these track bars in order to change the value of lower and upper HSV values. So first of all, let's set this mask for the blue color. So I'm going to just move it to 110 as we have done in the last step, and then this will be around 50, and this also will be around 50. Okay, so let's move it to 50, and upper value here will be around 130, right? So you can see once again, using this track bar, it's easier to adjust these lower and upper boundation. And now you can see all the three blue colored balls. So you can refine this object detection by moving these track bars little bit left or little bit right. You can see here. Now let's adjust this value to detect some other balls. So let's say we want to detect the green balls. So let's see what happens when we just change the saturation values here, and you can see now you almost see the green values, and the blue color is almost disappearing. So you can see now there are only green balls which are detected, and all the other balls are masked. So you just need to play with this track bar for the lower HSV values and the upper HSV values, and you will be able to detect the object, whatever colored object you want to detect from the image. Now this is the object detection from the image. Similarly, we can use the same method in order to track an object from a live video. So I'm going to just escape to just close all the windows. And in order to change this code for the video input, what we can do here is we can just add this code. So we are going to just add the cap variable, which is the capture variable, is equal to cv2 dot video capture. So we are going to use this one, and we are going to capture the video from our default camera, which is at the index 0. And then you already know how we can read the values from the camera input. So I'm going to just comment this code, and instead of reading the image, what we are going to do is we are going to write underscore comma frame is equal to cap dot read, which is going to read the frames from your default camera. And at the end, when you are done playing with your images, you can just destroy this cap using the release method. So you can just write cap.release, which is going to release all the cameras you are just capturing, right? So now this is the 3-line code you need to use in order to capture the camera input and then track any object of any color. So I'm going to run this code now, and you can see I'm just holding a blue colored object here, and I'm moving this object on the left and right, and you can see only blue colored object is detected and every other frame value is masked. So this is how you can do the object tracking of any color using the HSV color space. So you can see the real image which is captured from the camera, and then the mask, and then the result of the mask and the real image in this blue colored object tracking. So this is how you can do object detection and object tracking using HSV color space. I hope you have enjoyed this video, and I will see you in the next video.